In this video, we will overview the Data Encryption Standard, or DES. DES takes a 64-bit plain text and a 64-bit key and produces a 64-bit ciphertext. Notice that although the key is 64 bits, the effective key size for DES is 56 bits only. These are the actual bits that are used in the subkey generation. In encryption, the plain text passes through an initial permutation, then 16 rounds of expansions, substitutions, and permutations, followed by a swap of bits and an inverse initial permutation. The effective 56-bit key passes through a left circular shift, followed by a permutation to produce the subkeys used for every round in the encryption process. These are the operations that happen in every round of a DES encryption. The 64-bit input is divided into two 32-bit parts. The right 32-bit part is first processed through an expansion process to output 48 bits, which are XORed with the subkey for this round. The output of the XOR is processed through a substitution box, which outputs 32 bits. That output is permuted, then XORed with the left 32 bits of the original input to produce the right part of the round function output. And the right part of the input now becomes the left part of the output. This output is then used as the input to the next round function. The 56-bit key is divided into two 28-bit parts. Each part is left shifted, and the output of the left shift is processed in two ways. First, it is permuted to produce the subkey for this round. So, if this was the first time this process happens, it will produce K1, which will be used with round 1. If it was the second time, then this will produce subkey 2, which will be used with round 2, and so on. Second, this output of these left shifts act as the input to the next subkey generation process. In the next video, we will look at the details of encryption and subkey generation of DES using a simplified version of DES called SDS.